this video we'll discuss question 36. Choose an appropriate expression for the number of clock pulses that are counted during the discharge interval of the ADC from figure 7 and figure 8. And then 8 options are given for this expression. The ADC that we are going to investigate is a dual slope ADC as indicated in figure 7. And the operation of this ADC happens in 2 phases. The first phase takes a fixed interval and requires us to connect the input voltage to an integrator, which will then integrate a voltage signal with a certain fixed slope. Then in the second phase we will flick the switch here, connect the input of the integrator to some reference voltage. The slope will now be fixed, but the amount of time it will take to reach 0 again is now a variable. This question asks us to describe the number of discharge clock ticks in terms of the parameters of this circuit. So those are parameters like VA, Vref, the timing interval T1 and the clock frequency, and perhaps even the parameters R and C. We can start by making a sketch of this integrator, so let's do that first. So at the output we will measure a voltage called V1, and at the input we will assume that we are operating in the first stage now, so there will be voltage VA. We can now apply some nodal analysis to this inverting input, of which we know that the potential has to be 0 volts, and that will give us the following equation. And we can now rewrite this to get the following. We can now solve this equation by integrating both the left and the right hand side with respect to time. That will give us this. This initial condition will be 0, because when we look at this graph we will start this fixed interval always at a potential of 0. So this term will disappear. We can then evaluate the voltage at T1, which is the end of the first fixed interval, and that will also be the difference in the voltage for the first phase, and that is then negative VA over RC T1. We can now perform an identical analysis for the second stage, in which the input voltage is Vref and the interval is T2, but we're going to omit the calculations here, so that will be... We should now note that the delta that we're going to see in this potential in the first stage is the negative delta that we're going to see in the second stage, because we end up at 0 again after the second stage. So delta V1 is negative delta V2. And if we rewrite this, that'll give you that T2 is the same as negative VA over Vref times T1. The last step that you should take is note that T2 is actually the same as the number of discharge clock ticks times the period of a clock tick, because T2 is by definition the length of this discharging period, which can then be counted in terms of some integer number of clock ticks. So that's the same, and that means that your final answer will be negative VA over Vref times the clock frequency, because we divide by this clock period at both sides, and T1. And that's the final answer.